Special right triangles. Do you remember what the heck I'm talking about when I say special right triangles? 30, 60, 90, that's one of them. And 45, 45, 90. You got a preference on which one we do first? Okay, doesn't matter to me. Let's go 45, 45, 90 first. $45, $45, $90. All right, now I'll be super impressed. Does anybody remember the pattern that goes with 45, 45, 90? Yeah, like what are the sides? Let's go with X's or A's, however you. So which sides are the X's? Yeah, the two equivalent sides. If they're both across from 45, they're both equal to the same thing. So if those two are X, what's the hypotenuse? Do you remember what the pattern is?
Square root of X.
No, but it involves the square root and it involves X, so you're on the right track. Well, if we're stuck, we can do it this way. C squared equals X squared plus X squared. So C squared equals 2X squared. And then if we square root both sides, the X squared we can take the square root of and get X. And then we're left with the square root of 2. So that missing side is X square root of 2. So does that look familiar? Some teachers, I think, do A square root of 2, X square root of 2. Either one, same thing. So let's do an example, maybe an easy example. Let's find the missing sides, find the missing sides if one of the legs is 3. I mean, this is a pretty easy one. What's the missing leg? What's the other leg? 3. And what's the hypotenuse? 3 square root of 2. Like, that's the easy one. Let's do one that's a little bit harder. Let's do one where the hypotenuse is 1. That's going to be a little bit trickier. So for this one, I think I would label the sides. And then if I can figure out what X is, well, then I'll know the two missing sides. So if X square root of 2 equals 1, then X equals 1 over square root of 2, but we don't like that. So if we fix that, multiply top and bottom by square root of 2 over square root of 2, we get root 2 over 2. Okay with that? Hold that thought in your brain and look at the unit circle, especially the first quadrant. And we're not going to do this much because it would really crud up our unit circle, but I'm going to draw one of them. I'm going to draw the triangle from the pi over 4, from the 45. Now, if I was really paying attention or planning ahead, and we have done this before, but it takes some work, we can cut out triangles that fit exactly there and to kind of help us see That triangle. So do you see the right triangle I'm looking at here?
Yeah.
What's the hypotenuse of that right triangle? 1, because all of those radii are 1. And then, even though there's a whole bunch of other stuff going on, can you see that that's the same triangle we were just working with? It's 45, 45, 90. It has a hypotenuse of 1. And how long did we say this side was? Root 2 over 2, and that's the x coordinate. So root 2 over 2. And so those blanks are, again, not really blanks. They're more like fraction bars. What about the y coordinate? Same thing. I mean, for the pi over 4s, the x's and y's are going to have the same values. Signs might be different, but same magnitude. So root 2 over 2 and root 2 over 2. Yes. I was just trying to ponder, do we want to finish the first quadrant or do we want to start flipping things? But since you noticed it, over here at 3 pi over 4, it's kind of the same triangle, right? It's flipped over. I'm not going to draw any more triangles because then I'd have lines all over the page and that'd be kind of crazy. But you sort of visualize that triangle there. Do you know what the x value would be right here? Negative. It's the same as this one, but we're going backwards. So negative root 2 over 2. Well, what about the y value? Positive because it's up. Well, while we're in the pi over 4 mode here, let's just jump to 5 pi over 4. That's the middle angle in the third quadrant. It's definitely root 2 over 2 because they're all root 2 over 2. What about the plus and minus? They're both negative. And then into the fourth quadrant. Again, the side links are all root 2 over 2, but who's positive, who's negative? X is positive, and the y is negative. So there's all our pi over 4s. So all the values are the same. You just have to worry about whether it's positive or negative. But that's not really hard because left is negative, down is negative. Like, we're good with that, I think. All right, let's jump back to our special right triangles. And you might see where we're headed with this. Let's look at a 30, 60, 90 right triangle. Now, I'd be super impressed if somebody remembers the side links of the 30, 60, 90 right triangle. Okay, good. The hypotenuse doubles the shortest leg. So let's call the shortest leg x, and the hypotenuse is 2x. Absolutely, that is correct. And then there is some weird root number. It's the square root of 3, and so it's x square root of 3. I'm impressed. I am. So let's just jump to the case that matters here. And if we're thinking about the unit circle, which side length am I going to label and what's it going to be? If I'm peeking over here and I'm thinking about this blue, for me it's the blue triangle. What do I know about the blue triangle? What side length do I know? The hypotenuse is 1 because all the hypotenuses are 1. And then if I can figure out the other sides, I'll know the coordinates peeking back at the unit circle. So let's label the pieces. X, 2x, x square root of 3. So you guys remember doing this in geometry? sort of. You kind of matched up what you knew and then used that for the rest of the problem. So if 2x is 1, then x is 1/2. And if x is 1/2, then 1/2 times the square root of 3 is root 3 over 2. So if the hypotenuse is 1, the short side is 1/2, and the long side is root 3 over 2. Back to the unit circle. For our 30-degree marker, let's see. Again, I'm visualizing the triangle. I don't want to draw it because my picture would get too cruded up. But I've got a right triangle in there with a hypotenuse of 1. We said the short side is 1/2. The short side is 1/2. Which coordinate is that? That's the y coordinate. So the y coordinate is 1/2. The long leg, not the hypotenuse, but the long leg, how long was that? Root 3 over 2, and that's the x value, root 3 over 2. Well, now you can do that same thing where you copy it around. So why don't you try to copy that, not exactly, you got to adjust the signs, but copy that over 6 angle into the other 3 quadrants. I'm going to press pause while you do that, and then we'll compare answers. So up here, our triangle's turned around a little bit. And so, yeah, you can go through the whole point of drawing the triangle that looks like this, if you want to. But it's still a 30, 60, 90 triangle. But the short side, the short side is still 1/2. And so where does the 1/2 go on this? That's the x. So the short side is 1/2. And the long side is root 3 over 2. And so in that first quadrant, there's really only 3 values. There's a whole bunch of stuff going on. There's only 3 values you have to know. The short lengths are 1/2. The long lengths are root 3 over 2. And the middle lengths are root 2 over 2. And that's the case all the way around the triangle. So you go over there to 2 pi over 3. Let's see, the x distance is the short length for 2 pi over 3. So that's got to be 1/2. But it's negative because we're going backwards. The height, the y distance, is the long side. So that's root 3 over 2. And so I'm going to use short, middle, long most of the time. Because if you can figure out from the picture if it's short, middle, or long, you've got your answer. Because all of the short sides are 1/2. And all of the long sides are root 3 over 2. All of the short sides are 1/2. And all of the long sides are root 3 over 2. And then it's just a matter of, are you positive or negative? But that's pretty easy based on the quadrant. Okay, so we filled it all in, but there's a ton of symmetry. So it's not 66 or 64, how many blanks there are. It's understanding the unit circle. Audrey, did you have a question?
I think in quadrant 3 you missed something.
Uh-oh, did I mess something up? I definitely did. Because everybody should be negative or at least the x's and y's should both be negative in the third quadrant. Good catch. So let's come up here and make some summary type things. So if you got it, not counting the quadrantals, the quadrant markers are easy because that's just 1, 0, 1, negative 1, whatever. But the sides of triangles, the short side is always 1/2, the middle side is always root 2 over 2, and the long side is always root 3 over 2. Always. And so that takes some of the memorizing out. Like if you know that, then you can look at the picture and be like, if it's a short side, it's 1/2. I don't have to think through 30, 60, 90 and draw a triangle, and just all the short sides are 1/2. Let's say something about the angles that I don't think I've said in here yet. All of the blue angles, for me, all of the blue angles, all the over 6 angles are shallow. This is how I'm going to solve all my unit circle problems. Is the angle shallow or middle or steep? And if I know that, then I know who's short, middle, or long, and then I can get my values. So on my angles, anything over 6 is a shallow angle. Anything over 4 is in the middle. And anything over 3 is steep. So that helps me locate my angles. And then once I locate my angles, it's really easy to see who's short and who's middle and who's long. There's one more connection to make on this unit circle. So let's go back to our 30, 60, 90 triangle that we drew. And I guess we could do either one of these. Let's do the one that, let's look at this one. So we have those values. Let's find the cosine of 30. And then let's find the sine of 30. So cosine is adjacent over hypotenuse. So which side is adjacent to 30? Well, you could go with, actually you could use either one. You can use the x's, or you could use the side links. But let's use the side links. So what side length is adjacent to 30? Root 3 over 2. And what's the hypotenuse? 1. And that's what makes it nice, is on the unit circle, all of the hypotenuses are 1. So all of your sines and cosines have a denominator of 1, which makes things a little easy to deal with. So the cosine of 30 is root 3 over 2. How about the sine of 30? 1/2, because 1/2 over 1 is 1/2. So hold that thought, and then look at the unit circle, and look at the points, or look at the point, I should say, at 30 degrees. The x value is root 3 over 2, the y value is 1/2. The cosine is root 3 over 2, and the sine is 1/2. So this is kind of the big deal for the unit circle, is that yes, it's x comma y, but it's also cosine of the angle comma sine of the angle. So that's, I don't know how to get you to appreciate how big of a deal that is yet. It's a big deal. So the x comma y is the cosine of the angle and the sine of the angle. Remember, we've said this before, and you may have said it in physics. X goes with cosine, y goes with sine. And so now I can ask questions like, and this is the questions that we'll ask Friday and definitely in the next semester. If I ask you for the cosine of 2 pi over 3, don't anybody call it out loud, the cosine of 2 pi over 3. So you go to 2 pi over 3. You know that the cosine is the x-coordinate. So now somebody tell me, what's the cosine of 2 pi over 3? Negative 1/2. How about the sine of 270 degrees? The sine of 270 degrees. What's that equal to? Negative 1. So you go to 270 degrees. I said sine, so you pick off the y-coordinate. And it's negative 1. So soon enough, we're going to give you just a ton of questions like, What's the sine of 5 pi over 4? What's the cosine of pi over 3? What's the sine of 315 degrees? And we'll just rattle them off. And you'll get to the point where you don't need to look at the unit circle. It's fine. Right now you are looking at the unit circle, and that's okay. In fact, let's do just a couple more to make sure we're okay here. So write these down back on the non-unit circle page of notes. Let's just do one more. So try those 4. So there's those values. All right, that's a pretty good stopping point for today. So again, my encouragement to you, there's no homework today, except that I would love if you would spend 3 minutes at some point outside of this class looking at the unit circle. Nothing to do, just look at it and start realizing how much symmetry there is. I mean, you guys picked up on it. Like, all my blue ones are over 6. All the over 6s are shallow. All the shallows have the same coordinates, other than the plus or minus. And then the same thing happens with over 4 and over 3. So, yes, it's a lot of information, but when you understand it, it all fits together. So, no homework today, other than some point today, in another class, whatever, 3 minutes, pull it out, start looking at things and reminding yourself about shallow, middle, steep, short, middle, long, cosine goes with x, sine goes with y. It's a lot to fit together. The good news is we've almost finished the unit circle. Yeah. Tomorrow we'll talk about what tangent is, how to find that.